The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our next speaker is, we have two speakers, Mr. Fernando Buxo Saez and Jose Gaya Gil and Fernando is with Concrete Engineering Technologies out of Luquillo, Puerto Rico, and Jose Gaya Gil is from JR Technical Services, also of Puerto Rico. And they're going to be talking about the airport rescue and fire fighting facilities in Aguadilla, Puerto Rico. And they're going to be giving some case studies and talking about architectural concrete design and selection of materials and other issues. So, Jose, I believe you're up first.
Good morning to you all. My name is Jose Gaya, and I will be talking about the Rafael Hernandez Airport aircraft firefighting station. Locally in Puerto Rico, we are used to normal concrete, mildly reinforced concrete. After we form it up, we plaster it. It looks fine. We fix up any initial issues that we can find. Exposed concrete projects are limited for the most part. And one of the issues we have with contractors is that, hey, they look at their bid documents. They see, yeah, it's an exposed concrete project. Okay, fine. We'll bid it. And they bid it like a normal project. And they forget about the fact that, once they take the forms out, it needs to be looking pretty good, because if it doesn't, then it's a big issue trying to fix it. So this is sort of the case that we have ongoing right now at the Rafael Hernandez Airport fire station. This fire station is part of a wider master plan for the entire Aguadilla Airport. The Aguadilla Airport is the largest. It has the largest runway on the island of Puerto Rico, and currently it is starting to see more commercial airline type flights from the States. Usually it's most international and national flights come into the San Juan area. So this airport is ramping up their services and is going up to a different service level at this time. It's owned by the Puerto Rico Ports Authority, and it was designed by CDN Smith, and as a subconsultant we were the designer, JR Technical and Development. It's a federally funded project, 90% federal funds. And like I said, it's part of the general master plan for the airport. $4 million construction job. And it replaces an old aircraft firefighting station that was built back in the 1940s. Sort of a little bit outdated. The job was built to the UBC 97 code, the previous code of Puerto Rico. Now it's IBC, but when we were designing it was still UBC code. And obviously ACI 318, ACI 305 are hot weather because it usually doesn't snow in Puerto Rico. This is a view from the existing firefighting station, and in the background you're seeing the new job. Now the owner, when we first sat down with them to talk about this new project, one of the things that they were interested in is having a signature job. Is not your typical square firefighting station in front of an airport. The fact that they were bringing in some new commercial flights into the area from Miami, from different parts in the States, they wanted people to see a new face to this airport. Okay, not your typical airport. And so for those reasons, they were looking at the issue of possibly having an exposed concrete structure that would be different, that would separate it from your typical structures in the area. Our structure is a 2-story structure. It's got a footprint of about 1,600 square meters. It was designed on a grid, a 16 by 16 grid for modularity, and it's oriented towards sustainability. LEED wasn't an issue here. LEED certification wasn't an issue, but they still wanted to have a job that was, low maintenance cost, high durability, even if they couldn't obtain LEED certification. So it's a cast-in-place concrete, exposed architectural concrete, no exterior paint. And also for access to the second floor, we are not using elevators. We have a ramp access. There's 3 apparatus bays for firefighting vehicles as well. So what are some of our constraints here? Number 1, the climate. Puerto Rico, obviously, it's hot weather the entire time. Variations in weather, maybe at night you will get somewhere down in the 70s, but usually you're up in the 80s and 90 degrees and sometimes in the hundreds. In this particular area, you get heavy rains in the afternoons. This is a high seismicity zone. In fact, it's pretty adjacent to one of the largest earthquakes that we ever had, which was back in 1918, that also produced a tsunami in the Mayagüez area. This is in the western side of the island. And also there's coastal region issues. The airport is located about a mile away from the coastline. From looking at this, we have hot weather issues. In terms of sustainability and durability, we have issues of corrosion that we need to attack. And also, we need to also contemplate the fact that we're dealing with a high seismicity zone. And to us, what does that mean? Well, a lot of boundary conditions in our wall structures, which means, possible segregation issues during the pours of our concrete. Now, in our architectural notes, we were requiring the fact that exposed concrete walls must have a dense and smooth S-glass finish and an even concrete color. Therefore, the formworks must have a stable surface such as thin form panels. Reinforced concrete, we were limiting the water-cement ratio to 0.5. We would have limited to an even lower number if we were right at the coast, but due to the fact that we were separate from the coast and we had certain things that blocked us from the saltwater spray, we kept it at 0.5 at 4,000 psi concrete. Slump ranged from 4 to 8 inches in the specs. Concrete finishes was a rub finish. These were some of the forms that we were looking at prior to starting the job, and we approved. And when the contractor got into work and he showed us what he was dealing with, we were pretty content that we were going to have a pretty good job. Unfortunately, during the execution process, all hell breaks loose. Batch plants, we had batch plant issues. We had casting issues. We have every type of issue we can find, we were getting them. Starting with a batch plant, we were having reports that some of these trucks were coming in after an hour and a half into the site. As a designer and not being at the job site on a daily basis, we were getting fed this information from the inspection team. During casting, and hey, they did do mock-ups at the beginning. The mock-ups looked absolutely beautiful. Great concrete. But when you're doing a mock-up and you're trying to convince a client that things are going to work, it's a different scenario than when you start doing this, when you start doing columns and slabs on a daily basis. So we had during casting we had a lot of evidence that, they were improperly vibrating the concrete. We were getting a lot of issues around the boundary elements of our walls. Obviously, improper care was taken for the high steel areas. And also, in some of these areas at my suggestion, I said, hey, why don't you start using external vibrators to deal with some of those hard to get to areas? And their response to that was using a hammer. You can see where we can have some problems there. First 400 cubic yards of the job site, under 4,000 psi concrete. They were, they ranged from 2,500 to 3,500. Never reached the 4,000 psi concrete we needed. So you can imagine the headache we're starting to get at this job. And obviously, the appearance of the exposed elements was showing a lot of segregation, especially at the bottom. If you looked at one of these columns, at the bottom area of the column, a lot of segregation issues. And also around the boundary elements, you're getting a lot of issues. So in the end, this is a typical sample of what we were looking at once they took out the formwork. And we had a lot of high porosity in the surface. We also had a lot of segregation issues. And in the end, you know, when we initially looked at this job before it was even started, we were thinking of something like this. Nice concrete. We were getting this. Again, we were thinking of something like this. And we were getting this. So now this is after the first, you know, about a quarter of the way into the casting of the columns. This is what we're looking at, and everybody's starting to get worried. And at that time, I thought that we needed, you know, one of our local concrete paramedics by the name of Fernando Buxo to come in. We suggested to the owner, and we suggested, strongly and emphatically suggested to the contractor that we should look into troubleshooting some of these issues with a concrete engineering expert. I wanted somebody to come in, review the mix designs, look at the casting operation, also look at the batch plant operation. In general terms, I wanted a full review of the quality control from the point where you're coming out of your batch plant to you're putting your concrete in place. So at that, I'd leave Fernando to talk a little bit about what we did at that point. Fernando?
Thank you, Jose. And as Jose said, I was fortunate enough to be chosen as the janitor for working with this case. And basically, we were facing typical construction problems, but the special aspect of it was that we had architectural requirements. So concrete itself makes us face difficult challenges just by its nature. Concrete process is very difficult. It's a compound material that it's made of different materials that you need to keep quality control of each material, and then you have many people working to achieve that. So you have different points of view trying to make one thing happen. Not only that, concrete is a product that we sometimes or many times forget that it's a manufacturing process. What makes it challenging and difficult is you are still manufacturing concrete until the point of placement. Contrary to, let's say, building blocks, where you have your blocks already made, manufactured, and they're delivered to the job site, and you just take them down and stock them. So, facing all those challenges, now on top of that, we have hot weather conditions, and now we have architectural requirements. So, those are the things we needed to face. And to begin with, well, as Jose said, typically the mock-up is first thing is used to validate or to approve the mix. Since it's done in a small scale size, typically it's a vertical pour instead of a long wall, it always comes right. So now you have a high expectation or a high benchmark you have to compete with unfairly, because now along the project you will have different conditions, different length of structures, and you are required to comply with that first mock-up. So that's a challenge right there. And typically there's overconfidence before the pours begin, like everybody knows everything. The concrete plant, do you have it all set up? Yes, we have it all. We've done that many times until the first pour. And you have to work with the available materials regardless. There's still a budget. It needs to be constrained within some costs. So you have to face the challenge of making or meeting the requirements with any available materials that you have there. Special forms need to be used in architectural concrete. You need to have advanced placing techniques. Therefore, you need to have advanced skills from the people that are working with the concrete that normally you don't find that easily. Typically, it's very difficult to find good workmanship for regular jobs. Then when we start working with architectural, it becomes more of a challenge. And it requires strict planning and involvement from everybody in every phase. Everybody meets, and no one has any problem of meeting after a problem has happened. everybody will meet and talk about the problem, but it's very difficult to have people meet before pours happen. And that's where really you want to have the planning, the roles, and everything set up. So you need to think of pre-pours and after-pours meetings. And special inspection controls, because typically the inspector is not related to concrete production. And the core and the heart of the success of these types of project is the concrete as a material. So if you're inspecting concrete in the job site and you don't know what's in it, concrete comes in a drum, it's emptied in a pump hose, hopper, and then it goes through the hose, so you barely see it, you don't know exactly what's going on. So it requires that the inspection understands concrete as a material and understands the process and the controls that need to be implemented where concrete is manufactured, and that is in the batch plant. So that's a challenge right there. And it's unforgiving. Once you strip out the forms, as Jose said, it needs to be good. There's no room for repair, and high expectations are always there. But when you then add hot weather challenges to architectural concrete, then it becomes, even more a challenge. So you need to have special mixed proportioning considerations. You have to consider the initial temperature of the concrete. You need to provide for enough travel time, plus the time that the concrete is going to be emptying in the job site. Sometimes we think about the 90 minutes, but we don't consider that you have 45 minutes travel to the job site, and then you only have very small period of time to do your pour actually. You have to provide for slump retention, make provisions to prevent plastic and drying shrinkage, and control the water addition at the job site, which in hot weather becomes significant and critical. And dealing with architectural concrete, water, it's vital, it's essential. Water will turn red into a pink, and then variations in water will lead to variations in color. So same thing with the exposed concrete where you don't have any color. You have whitish concrete, and then if you have less water, you have more grayish concrete. Besides all the shrinkage and other defects related to that, meaning segregation and so forth. And with hot weather, everybody needs to understand what's the difference between retempering and the design water. That's a very sensitive subject. There's no too much knowledge regarding what you can do at the job site with the truck. And unfortunately, as an inspector, you lack of information from the concrete plant as how much water are you allowed to put into that concrete? It's whatever they put in the ticket. So is it retempering water, or are you actually putting some water that it's needed there? The important thing when you're dealing with architectural concrete is you want to make sure that you have all the water. And either if you're afraid to be retempering, you need to provide strict controls that you actually know that the water is design water and that you put it there, because the slump of the mix needs to be fluid enough so that it fills the forms properly. And then testing and inspection according to the hot weather conditions. And as Jose presented, the challenge in this project was in the mix itself and some placing methods. But they have it all set up. They have nice molds. They had a good setup. There was nothing particular about the rebar. It was a regular spacing rebar. But basically what they had was problems at the bottom and the edges of the elements of the structures. So you can see that they had some segregation, honeycombing, and right off, when you see that picture, you know that was as the result of lack consolidation. And a mix that would respond to that consolidation process. You see some of the wall finish defects. And I said unforgiving. In a regular construction, you just would repair that and you just go on. But that's not allowed in architectural concrete. So the mix requirement were the regular mix requirements of a normal mix. You have to provide enough workability and some retention so that the mix behaves properly and uniform along the pour. And when I say along the pour, it needs to be from yard 1 to yard 10. Testing labs typically take the sample out of the, say, second yard. And there you have your slump, say, 6 inches, if that was the target. And then after the 5th cubic yard or the 6th yard, then you have maybe a dropping slump, 4 inches. Then you're not completing the pour with the main slump. So you have to provide all those fret stages, requirements so that you can provide the contractor a constructible mix that he can put into the mold and make an architectural concrete structure. So we looked into the mix and we revised the aggregate total gradation, the unit water content. We were meaning to reduce any extra unwanted unit water content demand. We wanted to have that unit water content as good as possible with the materials that we were dealing with. We used the hydration control admixtures, and we made sure that potable water was used and not recycled water just to maintain consistency in the mix. And when we went into the mix, there you have a individual retained particle analysis of the total gradation in the mix. And basically you have mix 1, which was the mix that they were using. You see that it has, like a regular mix, the haystack shape, but it carries a lot of 1 3/4 inch stones. So to be able to consolidate into those corners, we needed to drop that amount a little bit down and then increase what the mix was lacking, which was the intermediate sizes. You see the blue columns represent the current mix. You see that the number 4 sieve lacks of enough sizes. So what we did was reduce the amount of the coarser aggregates, put some more of the intermediate aggregates. That way we were able to reduce the amount of water. Now we have more pace, we have more workability, and we ended with a concrete like this. And as you can tell by the picture, you can see that it's uniform, it has enough paste. We were able to increase the coarse aggregate content by 100 pounds. So even by shaping the whole curve, we were able to actually increase zoning and have a better workable mix, and that was the result. You can see that slump, and you can see that it will lead you to a wall like this. That's an actual wall from that project. To make this happen, and I think this is where we really need to improve when we're dealing with concrete, is that Jose provided very flexible and strict and, say, adequate specifications to make all this happen. But then enforcement and inspection, that's where you really want to make this all happen efficiently. So what we did was, instead of inspecting concrete already made in the plant, instead of inspecting it at the job site, we went into the concrete batch plant and we inspected process within the concrete batch plant. Checking on the aggregates conditioning, making sure, which is a critical aspect of hot weather, making sure that the aggregates were wetted properly and the moistures were taken, moisture contents were taken. Puerto Rico, you have rain, sun, so you need to keep up with the moisture changes, and that That's part of the total water control. Make sure that the batch weights were within tolerance. That's critical. Changes in proportions will change the behavior of the mix. So we went in and made sure that we had batch plant covered and then went into the job site and made sure that the permitted design water was allowed to go in. Since we're at the plant and we know how much water actually is there left to be put, it needs to be put at the job site. Sometimes the inspector, because of the lack of knowledge, won't let anybody touch the concrete and put water into it. But yes, you have a certain amount. Make it happen. Any retemperant needed beyond that point, then you do it with super plasticizers, which are allowed. That's part of the natural hot weather treatment for concrete at the job site. So once you start pouring, you need to make sure that the slump is being kept along its way. 5th yard, 8th yard, the 10th yard will go in. So you need to make sure that that slump is being consistent and have record, part of the inspection recorded, so that there's some evidence that it happened that way. Being consistent, not with the construction, not with the concrete production, but the inspection itself. The inspection needs to provide more of a quality assurance instead of a punitive point of view. So, as you can see in the placing process, you see how they are putting concrete at this side and then the vibrator is here. Who's vibrating all that concrete that goes above there? The layers that are being created, who is vibrating? So you need this vibrator to be along with the placing methods. And what I mean by that is, that concrete falls something like this, then you need to make sure that while the concrete is filling the forms, you do enough vibration in the corners so that the bottom layer, which typically is the one that you don't reach, because once you have more than 1 or 2 feet concrete layer, it's impossible to make it consolidate. So you want to attack that concrete within the form quickly, efficiently, and move along with the concrete stream. And those were the results. That was the owner's expectation. Those were the designers' views about the structures. So finally we made it happen. And that's the way it looks now. Basically, those were the measurements. If anybody has any question, I'll gladly. Thank you so much. Well, they were used. Maybe you want to talk a little bit about that.
Repairs continue to be an issue as we speak because they looked at several materials orders, but the reality is that most of the color, the difference in color is ridiculous. So it's an ongoing process that yet to be resolved.
The approach that we did from the concrete standpoint was to work with the product repair manufacturer to twist the color a little bit and make sure that it got as close as possible. We needed to work with and tweak their standard product, tweak it a little bit with the materials so that it looked more like the concrete that we have. But it's still an ongoing process, as Jose said.